So in this chemical equation, we have iron disulfide reacting with oxygen gas and producing iron 3 oxide along with sulfur dioxide. So now let's determine how many atoms we have. We have 1 atom for iron, 2 for sulfur, 2 for oxygen, 2 for iron, 1 atom for sulfur, and then 3 plus 2 gives me a total of 5 atoms for oxygen. Next, we need to identify the loner. That is the one that is not part of a compound. So in this chemical equation, that would be oxygen gas. So make the habit of leaving the loners, if possible, towards the end. So now we need to identify the 1:1 ratio, also known as the pair element, and that is the one that appears one time in the reactant side and one time in the product side. And it doesn't matter if the subscripts are different, and they can be part of a compound. So iron, it appears one time in the reactant side and one time in the product side. 1 and 1. Sulfur, 1 and 1. Oxygen, it appears one time in the reactant side, but 1 and 2 times in the product side, so it's a no. So now we need to start with the largest 1:1 ratio, also known as the pair element, and that would be the one that has the largest subscript. Notice that in this example, from the ones that we put the check mark, sulfur and iron both have a subscript of 2. You can start with either or. They're still going to give you the same answer. I'm going to start with iron because it's a little bit more simple to balance this chemical equation. So I have 2 atoms for iron. So I'm going to lock this in with a 1. So that means I need to come over here and I need to write a 2 for the coefficient. And then at this point, my irons are balanced, at least temporarily. Now, when I change this to a 2, it also changed the sulfurs. So I have 2 times 2 gives me a total of 4. So I need to write 4 in here. So that means I'm going to come to the product side, and I need to have a 4. So I'm going to write a 4 in here. And notice how we're ending with the loner. So let's determine how many oxygens we have now that we have made some changes within the coefficients. So for oxygen, I have 1 times 3 gives me 3. And then 4 times 2 gives me 8. So 8 plus 3 gives me a total of 11. Now, in here, I'm going to say 2 times what number gives me 11. The 11, I'm getting this 11, I'm just getting it from here. If this is too hard for you to figure out, think in the sense of decimals. And if decimals is too hard to understand, then think about it in the sense of money. Two times $5.50 is going to give me 11. So therefore, I'm going to write 5.5, or you could also write 5.50. I'm going to leave that temporarily. However, you have to realize that you cannot have decimals. So you have to multiply everything by 2. That is the standard rule. And this 2 is going to be distributed to every coefficient. So now 2 times 2 gives me 4. And then 2 times 5.5 gives me 11. 2 times 1 gives me 2. And 2 times 4 gives me 8. So now let's see if our equation is balanced. I'm going to rewrite it more neat. So now we have 4 irons, and then 2 times 2 also gives me 4. Now for my sulfurs, I have 4 times 2 is 8. And over here on the product side, I have 8 of them. And then on the reactant side for my oxygens, I have a total of 11 times 2, which gives me 22. And then on the product side, I have 2 times 3, gives me 6. And then 8 times 2 gives me 16. So that also equals a total of 22. So at this point, everything is balanced.